Several manufacturers produce out-of-phase devices, including Phase Perfect, Static Phase, Phase IQ, and AccuPhase. When considering whether to use an out-of-phase device versus having the utility bring in three-phase power, several factors must be weighed. Here are some of the pros of using an out-of-phase device. Firstly, lower cost. Installing an out-of-phase device is typically less expensive than bringing in three-phase power from the utility. Secondly, faster installation. Out-of-phase devices can be installed in a matter of days or weeks, while extending three-phase power may take months. Thirdly, less disruption. Installing an out-of-phase device does not require digging up the property or disrupting the surrounding area. Fourthly, improved efficiency. Out-of-phase devices can help improve the efficiency of single-phase equipment, reducing energy consumption. Now let's talk about the cons of using an out-of-phase device. Firstly, limited capacity. Out-of-phase devices have limited capacity, so they may not be suitable for high-power applications such as a 400 amp service. Secondly, potential harmonics. Out-of-phase devices can introduce harmonics into the electrical system, which can cause interference with other equipment. Thirdly, maintenance costs. Out-of-phase devices require regular maintenance, which can add to the overall cost over time. Fourthly, reliability. Out-of-phase devices are not as reliable as dedicated three-phase power, and they may fail during critical operations. To accurately evaluate the cost differential between these options, you will need to consider the following factors. Firstly, installation costs. This involves the cost of installing three-phase power from the utility versus the cost of installing an out-of-phase device. Secondly, maintenance costs. Consider the ongoing maintenance costs associated with each option. Thirdly, energy consumption. Evaluate the potential energy savings offered by out-of-phase devices. Fourthly, reliability. Assess the reliability of each option and the potential impact of an outage on the restaurant's operations. Harmonics are generated when nonlinear loads draw current in abrupt pulses rather than in a smooth sinusoidal manner. These non-sinusoidal currents cause voltage distortion on the electrical system. Common sources of harmonics include variable frequency drives, electronic ballasts, and other devices with nonlinear electronic components. Harmonics can cause a variety of problems, including overheating of equipment, nuisance tripping of circuit breakers, and inaccurate readings on metering devices. Harmonics are odd multiples of the fundamental frequency, which is typically 60 Hz in the United States. For example, the third harmonic is 180 Hz, the fifth harmonic is 300 Hz, and so on. Total harmonic distortion, or THD, is a measure of the amount of harmonic content present in a waveform. It is expressed as a percentage of the fundamental frequency component. A high THD indicates a significant amount of harmonic distortion. Mitigation techniques for harmonics include using harmonic filters, line reactors, and isolation transformers. Harmonic filters are designed to block specific harmonic frequencies from propagating through the electrical system. Line reactors can help to reduce harmonic currents by increasing the impedance of the circuit. Isolation transformers can block the flow of harmonic currents from one part of the electrical system to another. The choice of mitigation technique will depend on the specific characteristics of the harmonic problem. Out-of-phase converters, also known as phase converters or phase generators, are devices used to convert single-phase electrical power into three-phase electrical power. They are commonly used in situations where three-phase power is required but only single-phase power is available, such as in rural areas or older buildings. There are two main types of out-of-phase converters: rotary phase converters and static phase converters. Rotary phase converters use a motor generator set to create the third phase of power. A single-phase motor drives a three-phase generator, which produces the three-phase output. Rotary phase converters provide a balanced three-phase output and can handle a wide range of loads. They are generally more expensive and require more maintenance than static phase converters. Static phase converters use capacitors and inductors to create the third phase of power. They do not have any moving parts, making them more reliable and requiring less maintenance than rotary phase converters. However, static phase converters typically provide a less balanced three-phase output and have limited starting torque. When selecting an add-a-phase converter, it is important to consider the following factors. Load requirements. The converter must be able to handle the total load of all the three-phase equipment that will be connected to it. Voltage and frequency. The converter must be compatible with the voltage and frequency of the single-phase input power and the three-phase output power. Balance. The converter should provide a balanced three-phase output to ensure proper operation of the connected equipment. Efficiency. The converter should be energy efficient to minimize operating costs. Cost. The cost of the converter should be weighed against the benefits of having three-phase power. In addition to the type of phase converter, it's crucial to understand the different technologies used within each type. For instance, some static phase converters employ advanced electronic controls to improve voltage balance and reduce harmonic distortion. These advanced models may offer performance closer to that of a rotary phase converter, but at a higher cost. Furthermore, the sizing of the phase converter is critical. It is essential to accurately calculate the total load requirements of the three-phase equipment. Oversizing the converter can lead to inefficiencies and higher initial costs, while undersizing can result in overheating, reduced performance, and potential damage to the equipment. Consulting with an experienced electrical contractor is highly recommended to ensure proper sizing and selection of the appropriate phase converter for the specific application. When evaluating the cost of bringing in three-phase power from the utility company, it is important to obtain a detailed quote that includes all associated costs. These costs may include line extension fees, transformer upgrades, and any necessary permits or inspections. It is also important to consider the ongoing costs of three-phase power, such as higher electricity bills and demand charges. The reliability of each option should also be carefully considered. Three-phase power from the utility company is generally more reliable than an add-a-phase converter, as it is backed by a robust and well-maintained infrastructure. Add-a-phase converters are more prone to failure, especially under heavy loads or in harsh environments. If the restaurant relies on critical three-phase equipment, such as refrigeration systems or cooking equipment, the potential impact of an outage should be carefully considered. In some cases, it may be necessary to install a backup power system, such as a generator, to ensure continued operation during an outage. Based on the specific requirements of the restaurant, one option may be more cost-effective than the other. If the restaurant has a relatively small three-phase load and does not require a high degree of reliability, an add-a-phase converter may be a viable option. However, if the restaurant has a large three-phase load or requires a high degree of reliability, bringing in three-phase power from the utility company may be the better choice. It is recommended to consult with an experienced electrical contractor to assess the situation and provide a comprehensive cost analysis. An electrical contractor can evaluate the existing electrical infrastructure, determine the load requirements of the three-phase equipment, and provide recommendations on the best course of action. They can also obtain quotes from the utility company and provide guidance on the selection and installation of an add-a-phase converter. In addition to the factors already mentioned, it is also important to consider the potential impact on the environment. Bringing in three-phase power from the utility company may require the installation of new power lines and transformers, which can have an impact on the surrounding landscape. Add-a-phase converters, on the other hand, do not require any new infrastructure and can be a more environmentally friendly option. However, it is important to ensure that the add-a-phase converter is properly installed and maintained to minimize its environmental impact. The efficiency of the add-a-phase converter can also have an impact on the environment. A more efficient converter will use less energy, which can reduce greenhouse gas emissions. When selecting an add-a-phase converter, it is important to choose a model that is energy efficient and has a low environmental impact. Finally, it is important to comply with all applicable electrical codes and regulations. The installation of three-phase power or an add-a-phase converter must be performed by a qualified electrician and must meet all applicable safety standards. Failure to comply with these requirements can result in fines, penalties, and potential safety hazards. In the United States, the National Electrical Code, or NIC, provides comprehensive guidelines for electrical installations. Article 455 of the NEC covers phase converters. It outlines the requirements for installation, wiring, and protection of phase converters. Some key considerations from Article 455 include proper overcurrent protection, disconnect means, and grounding. Overcurrent protection is essential to protect the phase converter and connected equipment from damage due to overloads or short circuits. The NEC requires that phase converters be protected by overcurrent devices, such as circuit breakers or fuses, sized according to the converter's ampacity. A disconnect means is required to isolate the phase converter from the power source for maintenance or repair purposes. The disconnect must be readily accessible and capable of being locked in the open position. Proper grounding is essential for safety and to prevent electrical shock hazards. The NEC requires that phase converters be properly grounded in accordance with Article 250. Other relevant articles in the NEC that may apply to phase converter installations include Article 220, which covers load calculations, and Article 310, which covers conductor ampacity. It is important to consult the latest edition of the NEC and any applicable local codes to ensure compliance with all requirements. Proper labeling and documentation are also important for phase converter installations. The phase converter should be clearly labeled with its voltage, amperage, and other pertinent information. A wiring diagram should also be provided to facilitate troubleshooting and maintenance. The documentation should also include information on the converter's operating characteristics and any specific requirements for its use. Regular maintenance is essential to ensure the continued safe and reliable operation of the phase converter. Maintenance tasks may include inspecting wiring connections, cleaning components, and testing the converter's performance. A qualified electrician should perform maintenance in accordance with the manufacturer's recommendations. ADA-phase converters can be a cost-effective solution for providing three-phase power in situations where it is not readily available. However, it is important to carefully consider the factors mentioned above to ensure that the converter is properly selected, installed, and maintained. Consulting with an experienced electrical contractor is highly recommended to ensure a safe and reliable installation that meets all applicable codes and regulations. Furthermore, advancements in phase converter technology continue to improve their performance and reliability. For example, some modern phase converters incorporate digital signal processing, or DSP, to precisely control the output voltage and current. DSP technology can improve voltage balance, reduce harmonic distortion, and enhance the converter's ability to handle challenging loads. In addition to DSP, other advanced features may include automatic voltage regulation, or AVR, and power factor correction, or PFC. AVR helps to maintain a stable output voltage even when the input voltage fluctuates. PFC improves the efficiency of the converter by reducing the amount of reactive power it draws from the power source. These advanced features can improve the overall performance and reliability of the phase converter, making it a more attractive option for demanding applications. Another important consideration is the availability of technical support and service. When selecting a phase converter, it is important to choose a manufacturer that provides comprehensive technical support and service. This can be invaluable in the event of a problem or if you have questions about the converter's operation. The manufacturer should also have a network of qualified service technicians who can provide on-site support if needed. In addition to the electrical considerations, it is also important to consider the physical environment in which the phase converter will be installed. The converter should be protected from moisture, dust, and extreme temperatures. It should also be located in a well-ventilated area to prevent overheating. If the converter is installed outdoors, it should be housed in a weatherproof enclosure. The size and weight of the phase converter should also be considered. Make sure that the installation location can support the converter's weight and that there is enough space for access and maintenance. Finally, it is important to remember that ADA-phase converters are not a perfect substitute for true three-phase power. They may not be suitable for all applications, especially those that require a very stable and balanced three-phase power supply. If you have any doubts about whether another phase converter is right for your application, it is best to consult with an experienced electrical contractor or engineer. They can help you assess your needs and determine the best solution for your specific situation. In summary, the decision of whether to use an add-a-phase device or bring in three-phase power from the utility depends on a variety of factors, including cost, reliability, load requirements, and environmental considerations. By carefully evaluating these factors and consulting with qualified professionals, you can make an informed decision that meets your needs and ensures a safe and reliable power supply. Consider these points in your decision-making process and make sure that you receive the appropriate consultation from qualified professionals.